Hello everyone. So today's topic is about rate law, and we have to determine the unknowns k, m, and n, and this is just a generic formula to determine rate law. So let's see this question. Given the following data, write the rate law expression for the following reaction. A plus B produces C. Determine the overall order of reaction. Okay, so what we're going to do is you need to use two trials at a time, and you want to look at trials that will cancel out. So first, let's use trial 1 and 2. By doing so, following our equation, so this is trial 1, 0.5 molar per second equals K, 2m to the exponent m, 1 molar to the exponent n, divided by 1 molar per second equals K, 4 molar to the m, 1 molar to the n. So what happens here is you can start canceling out some of the variables that are the same. So for here, 1 molar n cancels out, the k's cancel out, and then here you get 0.5 divided by 1. This means you have 0.5 equals 2 divided by 4 gives you 0.5 to the m. And this value m, it must be a whole number. So either 0, 1, 2, 3, 4, etc. So based on what you have, m equals 1. One way to solve the exponent is to guess and check. Another way is to use log. But generally for these questions, you can just use guess and check. Now to solve for n, we can use trial 2 and trial 3. So trial 2 and 3. So by doing this, we're going to get 1 molar per second equals K, 4 molar to the m, 1 molar to the n, and then trial 3, we have 8 molar per second equals K, 4 molar to the m, 1 molar to the n, 2 molar to the n. So from here, we can divide them. And when you divide them, the k's cancel out, the 4m's cancel out, as well as the m, and now you're left with 1 over 8. So 1 divided by 8 gives you 0.125 equals, and here we have 1 divided by 2, which gives you 0.5 to the n. And if you can guess and check to get a value close or equal to, and you will get 3. So for now, we have m equals 1, n equals 3. Now you can also solve for k as well. So to solve for k, what you would do is you can just plug in any of the trials. So I'll use trial 1. So you have 0.5 molar per second equals K, 2 molar, and we've solved for m, which is 1, and plug in the value for b. So 1 molar to the exponent we just solved for n, which is 3. Now from here, if you solve it, you're going to get K equals 0.25. And in terms of units, you should get second -1 and molar -3. Something important to note is that the units for K will be different depending on the question and depending on the other exponents. So units will differ for the constant k depending on your equation. For this next question, we're going to use trial 1 and trial 3. And I'm doing this because I see that if I use this, the b's are the same and they will cancel out. So writing down trial 1, so 5 times 10 to the negative 3 molar per second equals K, 0.02 molar for A to the M, 0.01 molar to the N. All of this is over 2.5 times 10 to the negative 3 molar per second equals K, 0.01 molar and 0.01 molar to the N. Now from here, the K's will cancel out when you divide it, and the 0.01 to the N, 0.01 to the N will cancel out. So you're going to get 2 equals 0.02 divided by 0.01 gives you 2 to the M. This means that M equals 1. Next, we're going to solve for N. And to do this, I see that trial 1 and trial 2, the A's will cancel out. So I will use trial 1 and 2. So from here, you get 5 times 10 to the negative 3 molar per second equals, so this is trial 1, K times 0.02 molar to the M, 0.01 molar to the N. Divided by 4.5 times 10 to the negative 3 molar per second equals K, 0.02 molar to the M, 0.03 molar to the N. And now from here, we will start canceling out the K because this is the same. We can also cancel the 0.02 to the M. And when you divide it, you're going to get 1 over 9 or 0.11, but 1 over 9 is more accurate. So 1 over 9 equals 1 over 3 to the N. And when you solve this, you get N equals 2. Great. So now we can also use this to solve for K. So to solve for K, I'll use rate 1. So 5 times 10 to the negative 3 equals K. So A was 0.02 to the M, which we saw, which is 1. And then B is 0.01 to the N, which is 2, which we solved. Completing this, you should get K equals 2,500 second negative 1 molar negative 2.